Thanks everybody. We're here for talk about brewery maintenance. So if you're not here for brewery maintenance,
You are now.
you are now. Yeah, exactly. But first, a word from our sponsors at the USTA.
Brewery maintenance is brought to you by the USTA. And I know that several of you can recite what I've been saying before all of these sessions. For those of you who don't know who I am Rob Gordon. I'm with the United States Tennis Association, who is the USTA. We're the governing body of American tennis. And we also host this little tennis tournament, no big deal, in Flushing, New York. It's called the US Open. It's not a big deal. But anyway, so we are a giant nonprofit solely interested in growing tennis. Why are we here? Now why are we at a Brewers conference? Because we want to provide a solution for your gap nights. If you have a slow night, we want people in your tap room on that night. How do we do it? With tennis. Now I know that you're thinking, tennis, the stuff that I've seen, Roger Federer do. No. This is a slower, more accessible version of tennis. It's with modified rackets, smaller court, a slower ball, a tennis that everyone can play. What I've been doing in Orlando is I do a social league where we have teams play, and I have 50 to 85 players per season. I'm entering my 6th season, and it's a Tuesday night, and it's turned that slow night into a place to be. Plus, more importantly, we give you everything for free. Why do we do that? Because we are in the business of growing tennis. So our profit is people, not selling you equipment. So we are more than happy to give you the stuff. We're more happy to give guidance, and we're more than happy for you to do something tennis related in your tap room, whether it be a social league or brewery challenge or whatever you want to do. We're here to support you. So we're at booth 106 upstairs. Thank you very much, and enjoy the rest of the session. Thanks, guys.
All right, I'll introduce our speaker. Our next speaker is Chris Brogan. He's the president and founder of Ultimate Brew Service. It's been open since 2018. He's recognized for his ability to diagnose, repair, and maintain almost any piece of equipment. Before starting the company, he gained well-rounded experience in installing and fixing chillers, pumps, controls, and automation in the dairy industry. The past 8 years have been focused on the equipment used in sanitary beverage production sites. Ultimate Brew Service's mission is to sustain and improve craft beer production. Again, Chris Brogan and his colleague, Justin O'Donohue. Thanks.
Thanks, Jeff. So we're Ultimate Brew Service, been in business for 8 years, and our mission is to sustain and improve craft production. We do that by not having to spend money on new equipment all the time when it breaks down. So we want to make sure that what you have now is going to work for you for the next 5-10 years. Give you the tools on how to do that and what to look for in your systems. So today we'll be going through 5 main pieces of equipment: chiller, boiler, heat X, pumps, and air compressor. We'll go through easy maintenance, what to look for, what to just put your eyes on, and then a little more advanced stuff that you can maybe even tell your tech before you call, to be one step ahead. And we'll open up at the end for questions. There will be plenty, I'm sure. So, Chris, you want to talk about past experience?
As Lee said, I started in the dairy industry. I had a bunch of knowledge and whereabouts starting there. A lot of the processes and pieces of equipment are very similar to what breweries do, so it was an easy transition to get into this business. But currently we work with the beer industry. We've worked with the dairy industry. We still currently work with maple producers, cider producers, wine producers, even into the THC beverage market and extraction market as well. So we're doing a wide range of chillers, whether it's negative 70 degrees to beer chillers 28 degrees. We see a wide range of food processing equipment that not everybody really knows what they're doing. We're just trying to kind of shed some light in what you guys need to look for to know, hey, I can kind of maybe fix this problem, or I need to call somebody in here, this is serious.
So we'll start with the easy stuff. Fins on the back of your chiller condenser, whether it's, especially in the summer or in the winter, keeping an eye on it. If there's not flow of air going through that, you are not cool. There's no such thing as cooling. I just said cooling, but you're just removing heat. So without the fans to push that away, you are not cooling, quote unquote. So keep an eye on that, make sure that's clear. Especially in the summer, like I said, cottonwood
season.
Is also why, I guess, if most of you have your chillers placed already, but for some reason you do put a new one in, give yourself like a foot or two for, first of all, airflow, but also being able to get back there and actually remove the debris. So, keep an eye on it. Once a week, take a peek. In the summer, keep a closer eye on it. There's also a fan on your motor for your fans. So on the back of that, making sure that's clear as well. You can see that. Oh, look at that. Professional laser.
That's going to be the same, on like your walk-in coolers, your condensers, chillers, basically any piece of cooling equipment, you're going to have fan motors, right, guys? So you have to blow air past your motor to keep them cooled down and running properly and efficiently. That right there is pretty much totally plugged up, which isn't allowing the motor to cool. On a hot summer day, that's going to kick out, probably blow your capacitor up, eventually ruin your motor. So just by take a vacuum cleaner, right? Just vacuum that debris out of that. Allow the air to flow through the motor and breathe and stay healthy. It'll make it last, that motor, if it's staying like that, it's going to last maybe a year, 6 months. If you keep that clear, you should get 10 years out of it, right? So just keeping all your condensers clean too. That's going to be one of your bigger culprits on your chillers and your walk-in coolers. That's a quick way to ruin your compressor. If you don't have certain high limit controls, right, you're basically heating that discharge temperature up exponentially. So if we're not cooling that back down, the compressor's got to work twice as hard. Your energy bill has to work, a third as hard as well. So by keeping that cool, clean, we're running much more efficiently, and your equipment's going to last much longer.
So the bottom left is just an example of a professional cleaning. That's like a flowing caustic type service that can be provided. Secondly, just reservoir level on your glycol, monthly checkup on that, monthly checkup on your bricks levels, and then I'm sure there's some leaky pumps out there. Keep an eye on those. So there's your photos. That is your refrigerant site class. So this is a good indication when you're having like a cooling problem. Is take a look at that, see where it's at. If it's bubbly, something's going on. It should be perfectly clear and not any bubbles. Also, ice balls are fine in a small capacity, but when they look like that, something's going on. And then when you're having an issue, I guess, just check your contactor, see if it's actually firing or if it's something else. These are more just things to be able to present to your tech and hopefully get them one step ahead on their service call, so they're not wasting time.
Yeah, I hate to say it, it's pretty impressive how many chillers I can walk up to that look like this, right? If your compressor has a frost ball on it, something's wrong. And if your technician's telling you that's okay, then you might want to find a new technician. That middle chart there, right? So almost every manufacturer on a chiller has these site classes now. This is going to kind of show you your refrigeration charge. That's what's feeding your metering device that actually separates sides of the cooling. So right during fire up, you might see a couple bubbles right in the beginning of fire up, but in the middle of the running on a compressor, that should look like it did in the back one, basically totally clear. You don't want to see any bubbles flowing through that. If you do, it's a good indication that you're low on Freon. So, at that point you would want to call a technician in to find your leak and get it fixed. I don't know if everybody knows, but chillers are a sealed unit. You don't just lose Freon, right? Systems don't just lose Freon. If you have to charge Freon, there's a leak. So if there's a technician in your facility charging your chiller up, the next question you should be asking is, did you find the leak and where is it, right? Obviously burnt wires, if you guys are opening up your panels, it's good to open it up maybe once a year. Just look in there and see if you see wires starting to get hot. They can cause issues down the road, so it's just a good maintenance thing to open up your panels and make sure you're not seeing any of that stuff.
So on to leaks.
Yeah, this is a good indication. So like guys that do have leaks, if you do have leaks and you have technicians that can't find it, or it's a micro leak, it's super hard to find, there are other ways to do it. First thing you want to look for is going to be this oily residue. When refrigeration leaks, it releases the oil that's in the compressor as well. So it's going to come up as a very oily, sticky kind of residue that you're looking for. If they have super serious hard times to find it, you can inject the UV dye into your system that then you can go in with a blue light and seriously find hard to find leaks and things like that. So I try to recommend techs, use this as more of a last resort. But if you got a system that you're just struggling to find it, it's super small, they do make, fluorescent dyes that you can put in your chiller so that when your technician comes back, he's blue light in it and it's black and white of where the leak is, right? So
on to boilers. We have a Excel sheet that you may have in your facility that we would be happy to share if you follow up with us. This is for anyone with boilers, obviously, and it's something that you should be testing your blowdown water, once a month or so. Checking out, making sure it's in the general ranges. This is going to give you an idea of, okay, my boiler is healthy, or what do I need to do to adjust? And that's something we can also help out with. So, pH, obviously, alkalinity, conductivity. If they're in these ranges, you're in good shape. And often if you're in these good ranges, it's because you're feeding it with soft water, you have your chemical injection, and you're not turning your boiler off, which we'll get to. So this sheet is really helpful to just get a gauge on where you're at and if there's an issue and if you have to address it. There are many ways to solve these problems.
yeah, and this is kind of more of a generic form in an Excel sheet we have. Every boiler, you can ask your manufacturer, whether it's Columbia, Wright, Fulton, whoever it is, go to the manufacturer and say, hey, where's your recommended ranges? I know on a Columbia, it literally lists it right on the side, right? So we just got to make sure we're staying within those ranges. And by testing it every month, we're going to know if we're in those ranges, and we're going to know if something's going wrong with your softener, right? Your hardness starts to rise a little bit. You catch it. It's at 2-3 parts per million, or you should be at 0. So just by filling this out every month and getting in a habit of doing that, you're going to find the problems in your boiler before they become major problems. So getting in a good routine of checking out your boiler every time with a sheet like this is definitely recommended. It's going to keep you ahead of the game, going to keep you from preventing purchase major repairs.
So these are just examples of what the water, what we should be feeding in the boiler room. This is a really small boiler room that we built. Eric's familiar. So the far right is a chemical injection system. This is plugged right into your condensate return. That's the way we do it. And when that pump is on, so is the chemical injection. So it's just peace of mind. I know other people, you can dose it, with your hands, but when you take a little automation into it, you have a little more peace of mind and control. Water softener before keeps the life of your pipes nice and long. So this is an update from the previous presentation. If you were here last year, this is all looking very familiar. If this is your first time, obviously it's new, but over this past year we've found something that is going to help the life of your boiler, which is to not really turn it off. Instead of allowing your boiler water to get down to atmospheric temperature, have a aquastat temp controller on your boiler to maintain a temperature of 180-ish and plus. This will allow for the water that's been de-aerated to continue to be de-aerated and keep kind of a pressure force field in your boiler with that de-aerated and hot water. When you turn your boiler off, the temperature is going to be cooling down, which is going to bring in new air, oxygen, which is the enemy, right, of corrosion. And it's also going to feed back into the water, which is going to keep your water not de-aerated. This is an example of a pretty extreme example, but one that we've seen out in the wild, and it's purely caused by turning this off, every time you use it. Now there's obviously other factors at play here, like energy and everything else, but this isn't, this is a maintenance and best practice, seminar. Best case scenario, you're not turning your boiler fully off.
Yeah, just like brewing guys, right? DO is going to be the enemy here. DO is going to be your major enemy in your boiler. If you have de-aerated water in your facility, I suggest you feed in your boiler with it. Most boilers are going to have that feed tank that is being heated with the boiler to preheat the liquid and get it basically down to temp. But keeping it above 180 and basically airtight is going to be huge. Now, obviously, we want you to inspect your boiler every year, open it up, check out the insides, make sure we're going in the right direction. When you do that, you obviously have to shut it down and go. But there's techniques that you can get away with to try to prevent some of that stuff, whether it's like double dosing the chemical is usually a pH riser and an oxygen scavenger, right? So at the end of the day, we're trying to balance your pH and how much kind of alkalinity and oxygen scavenger is available to us if you are going to shut it down. We like to see almost like double dose your oxygen scavenger before you shut it down. If that's the route you choose, it's definitely not best practice. But in doing that, you're going to raise your pH above 11, so you're going to start to corrode your boiler there. So it's kind of a balancing act of where to find your sweet spot. Your best practice is going to be try to get an aquastat, put it in that boiler, leave it at 180 at all time. Basically, when you shut the boiler off, it's just becoming a hot water tank. It's keeping that liquid de-aerated. DO is going to be one of your biggest killers in the boiler. It corrodes the boiler from the inside. You're not going to notice it from the outside. It's going to corrode it from the inside out, and you're just going to notice it when it's leaking into your fire chamber. And then you're going to have to either replace your tubes or replace your boiler, which is not cheap, as we know.
Yep, don't want to do that. So this is our kind of a new piece to set.
Second question: are there any prominent red flags to look out for when your boiler is maybe not in good shape? Because I've heard some stories, kind of bad stories, that things happening. So just as a brewer walking in, is there anything specifically you could see as just know it's not in good shape?
Without an internal inspection, it's going to be hard to do that. So like if that's where you're at, I would suggest, yearly, maybe 6 months, open your boiler up and physically look at the internals of your boiler. Physically from the outside, you don't want to see that, right? You don't want to see corrosion on the front side, whether it's calcium, magnesium buildup, blowing out of your gaskets. If you have leaks, if you have any leaks in your boiler, take care of it, right? If you don't, it's just going to lead into a bigger problem that's going to cost you more money. That's really it. Yeah, just kind of look with your eyes. You'll know. You can kind of tell when the boilers don't look great, right? You walk in and you see a nice boiler. It's in pretty good shape. You don't see anything dripping on the floor. You don't see magnesium and calcium dripping down the sides of it. A good technician should be cleaning that stuff up during a maintenance. If they're not, then try to do it yourself or get it cleaned up so that you know if a new problem is coming. If you're kind of in that position.
John, you had a question?
High TDS in your boiler water isn't great, and if you have a sight glass on it and see that bouncing externally, you'll know that you have high TDS. that can cause problems later on down the road.
Amen. Yeah, for sure. And definitely keeping that sight glass clear too, right? If that sight glass is looking murky and rusty, you probably should be blowing down a little bit more. And that's where that sheet we sold you, or that sheet we showed you guys.
It's free.
Right. They make a conductivity meter on Amazon for pretty cheap. It doesn't have to be perfect, but at least it's going to get you close within a range. I would advise everybody to buy one. You can use it multiple places around your brewery. They're nice to have. But to your point, yeah, total dissolved solids is a big deal, and you want to keep that stuff blowing down and out of there. Great way is that sight glass, and conductivity is also going to read a lot too.
Just one quick comment for extended shutdowns, you could also put a nitrogen blanket on it, right?
Yep.
Just displace the oxygen
Yep.
in your gas.
Yeah. See, that's a great point. I don't know many breweries that have a port or a way to actually do that. You usually have to like add an external port and do something like that. But that, to your point, that is a great way to do it as well.
Okay.
We've even installed like instead of an aquastat, basically an aquastat to almost a heating element inside the boiler. So if you don't want to run gas, you kind of use a heating element inside your boiler if you have an extra port to be able to do that. My other concern is like your boiler feed tank. So the tank that comes from your boiler and actually feeds your boiler with water, you want to kind of keep that de-aerated as well. Because obviously that's what feeds directly into your boiler when you go to fire it back up. So you kind of want to watch both of those spots.
That's it for boilers, until we have questions maybe at the end. One of the easiest ways to protect your heat exchanger is to filter beforehand. Still, it's pretty impressive to know when people aren't still not doing this. It's a fairly simple way to eliminate any kind of obviously clogging in your heat exchanger, but also just debris that is from your brew day. I mean, it's going to sit in there. You can run, you can rinse, you can wash as much as you want. I mean, the plates are so fine. There's going to be particles in there. It just is. So filtering beforehand is probably the cheapest thing to do on this list, and give you peace of mind. I'd rather clog that than clog your heat exchanger. If you want to get real fancy, you can double up on filters, like on our systems, where you're never not transferring. You're able to just divert and rinse as you go along. So very simple thing to add into your preventative maintenance list. Here's just a couple of examples of what that may look like after time. Even if you are filtering, I mean, honestly, after many years, it could still very well look like this. The idea is to just do this very much less often because it is a pain, as I'm sure maybe you have done in your past.
So these examples actually came from systems that have a whirlpool boil kettle combo. So they're a conical bottom, and they're going to get a lot more of that hop debris coming through their heat exchanger. When you have a whirlpool tank, you don't have nearly as much coming through it. But still, it's great practice to have one of these things in front of hand, because obviously it's usually the hops. That's what I see more than anything else. You'll get hops up in these corners, up in these, it's hard to get areas, and I don't care what you use for chemical, it just doesn't come out of there until you physically take it apart. Now, yeah, it is hot side. You can say what you want, but this is going to create off flavors. You're going to taste it in your beer.
Oh, and just one note, I mean, maybe you've all done this before, but just be very diligent when you go about it. The plates are very specific as far as how they are placed, so
A good tip, yeah.
don't do it while you're doing something else.
Can I give a tip here?
Yes.
Yeah, if you got one.
While it's assembled, you can score them like diagonally, and then you'll have a visual cue.
So
you from being able to put them out.
we usually with a Sharpie, take a Sharpie and mark one corner.
Oh, sure, you could do that.
Take one corner and mark the whole corner, and then when you do the stack, best practice, if they're on a slide gate like that, just slide them one at a time, or the one on the left, put them down and do one plate at a time. Wash one plate, flip it over, put it back on. Wash one plate, put it over. Don't try to take them out, scatter them all over the place, and then think you can put it back together, because you're gonna have a hard time.
We all think we can multitask, but this is not one to do that with. honestly. I'll let you take the pumps.
Sure. So, I mean, obviously everybody has pumps in their brew house, and everyone once in a while has to change seal kits. If your brew house pump is leaking, change your kit, guys. You know, you could be entering DO into your beer, or if you were using it for transferring or anything like that. So there's two different type of seal kits on most of our pumps. We're going to have internal, which is going to be this top diagram, and external down here. Your internal is going to be used, I think, a lot more for some of your stickier liquids, mash transfer, even your boil knockout. External is a lot more seen on like CIP, pump carts, cleaning, things like that. Now, what I see most in breweries when we go to fix and repair these things is on an internal seal kit, a lot of times this seal is riding directly onto this back plate. When that back plate is, you know, a year old, it gets scored on the inside. So right on the very inside, of which we have a photo of later on, they get grooved. So when you put a new seal kit on a grooved back plate, you're significantly reducing the lifespan of that seal. Yeah, there you go. So one thing we do is we go back in and we'll remachine it. Either buy a new one, or if you have a local machinist, have them come back in there, resurface that plate clean, and then put it back together. If you go back a little bit, go back to the last slide, Justin. The next thing is going to be your adapter plates. So if they're mild steel and or if you have aluminum motors, what I see a ton of, if you have a pump, you're just like, man, I put a new seal kit, new back plate, I can't get this thing to stop leaking. Most likely what's going to be your cause is going to be the corrosion between this adapter plate and your actual physical electric motor. So if they're dissimilar metals and that corrosion builds on that back plate, you're trying to seal something that needs to come out straight perpendicular from your motor, your shaft, onto this back plate. And if this is tweaked at all, just a very tiny bit, you're now then trying to seal something, you know, that's not straight perpendicular to itself. It's going to wear one side down much faster than the other. So go to the next slide. The best thing you can do is try to clean this up the best you can. Realistically, I would say you probably should replace this. You can buy just these faceplates, but if you're looking in the used market nowadays, I suggest buying a stainless motor with stainless adapters. That's really the best case, because then you're not going to have this corrosion buildup. But that's what I see. You know, some of the cheaper pumps out there have aluminum mild steel adapters and aluminum faceplates, and they just corrode. As soon as the seal leaks, it rides the shaft back, comes down into here, and it pulls up, and it throws that adapter plate off. And once that's off, your seals might last a week. They're just going to continue to leak. Yeah, there's a great photo of it. Even this, yeah, it's a mild steel adapter. And you can see, it doesn't look like much, but right in between there, even on your faceplate with a mild steel adapter, it throws it off ever so slightly, and you'll just have a terrible time trying to get your seal kits to last over a month, 2 months. You know, realistically, a seal kit should last you guys, depending on how much you're brewing and your size. I mean, even the most proactive breweries, I want to see at least 6 months to a year. That's like a low end. You know, I like to see a year, maybe even 2-3 years out of a seal kit. But if it's only lasting a month, maybe 3 months, something else is going on, guys. Just dive a little deeper.
Yep, so the last piece of equipment is air compressors, just some best practices. You want to be feeding it with, well, not feeding them, but post compressor, having an air dryer unit to make sure you're feeding your equipment with obviously dry air. This will reduce any kind of corrosion and problems within the valves on your systems. Having filters before and after your air dryer. Be checking those out and keeping those updated, changed twice a year. You can see here just looking for buildup and the filters, making sure those are staying clean, and then you should be doing your oil changes as well. And that's all based on kind of your equipment recommendations.
Yeah, our usages.
And then belts, obviously look at those, keep an eye. Making sure those are running well. What else on air compressors?
Not really. Air compressors are pretty basic, guys. keep them up to date. Change the belts, change your oil, change your filters. Biggest problem usually is a canning line. If you have a canning line and you don't have an air dryer, I suggest you get one because you're just going to be ruining your valves.
So, last year we took a lot of questions. I'd be happy to get those firing. We have, 20, 30 minutes to talk about what's going on, and we can instill some of our knowledge and expertise of what we've seen. So, if we have any questions, it can be personal issues, I guess, in the brewery is fine. Feel free to shoot them away. Yep.
I have an email out to the manufacturer. I'm working with a flexible impeller pump, and it's relatively new. But I already have some leakage happening, and so. One of the strange things is when I'm using it to transfer mash with grain in, no leakage whatsoever. And I'm getting more leakage, but I get a significant amount of leakage if I use the pump per se to clean in place. And so I've been trying to figure out, and there have been one or two kind of exchanges via email, and they want to chat with me to kind of try to figure out better. But I was just wondering, is that a seal problem or is it something else?
Yeah, it certainly sounds like a seal issue to me. Yeah. Whether the alignment is off, definitely look at your adapters coming off your motor and make sure that there isn't the corrosion happening between your motor. Being brand new, I highly doubt any of that.
5 uses.
Yeah, that's crazy. I definitely stay back in touch with your manufacturer. There might be something from the manufacturer that could be a fault or a flaw or something.
Okay.
For sure. Wish I could.
It could be that you have a lot more head on the CIP than on the moving mash too.
Yeah, but even still, most flex impellers are like an internal seal kit. Yeah. What size? Yeah, that's a great point. I mean, what size tanks are you moving? A lot higher head.
I'm generally. I'm not sure exactly how much head I'm using.
I would say like 20 feet,
no,
30
I'm
feet would
sorry.
be concerning, maybe, to think about. But if
We're
it's not
talking
that,
6
then
feet.
yeah, you shouldn't be having that issue.
If you have like a mild steel or aluminum pump, aluminum adapter, is there like a gasket that you can make, or you can get, kind of like a head gasket on the border?
To be honest with you, so when we get them in our shop and I see them, I will physically replace the seat. So your electric motor has two ends bolted onto it, right? You have a bell end and you have the C face. That C face actually can be removed, and they're like $30-$40. You can buy a new one, put it on there, and then if it's a stainless steel adapter, you can bolt it right back up. If it's a mild steel adapter and the adapter's corroding on you, I would suggest replacing your adapter. Yeah. Awesome.
We were obviously very clear, and
Do you guys want to take a couple minutes to describe your services? Since you have
sure,
them?
yeah, sure, yeah. Obviously we provide all of these services. We'll be talking up here if we didn't. To be fair, we are pretty much just beyond Syracuse to Buffalo range down to the Finger Lakes as far as same day or regular service. We're open book.
Also, we take phone calls. I mean, if you guys have problems in your brewery, feel free to email us, give us a call, shoot questions by us. I mean, we go in 100, 150 different breweries through all over the place. So I see how everybody's, multiple of you guys have the same issues. And we're seeing all of it, right? So 9 times out of 10, if you have an issue, we've seen it 10, 15 times over.
And we do, we can have either a formal, over the phone service, and we're able to get people fixed in 30 minutes to an hour. Get your multimeter ready, and we'll literally walk you through.
Minutes or
I mean, we've definitely done.
Know the problem. We'll know the problem.
I mean, if you guys are able to read a multimeter and you have electrical issues, we're happy to FaceTime and diagnose and let you guys find the problem yourself with instruction behind us. We're here to help. We want you guys to do well, and if I can avoid you a $1,500 service call for a $100 phone call, we're happy to help.
Yep. That's how we started, you know. It's not bad.
Is there anything you can do for like lightning protection with your chiller?
Yeah, so most chillers, you're single phase though, right?
Yeah.
Yeah, so single phase, it's usually not as big of a deal, but you can buy surge protectors on your main power in. There's that. Obviously, most 3-phase chillers nowadays are built with a phase monitor directly in them. Single phase, they don't put phase monitors in them because if you lose a leg, it just isn't going to run. It's not going to usually hurt anything, but if you actually have those surges going on, a voltage monitor, even putting on single phase, would be the way to go. Yeah. It just monitors that voltage the whole time. If it dips beyond your settings, it can shut your chiller down right away. Yeah. They do, yeah. And if you're running 208 in a hot summer day, everyone's running their air conditioner, you're going to kick out at 200, and you're going to be like, my chiller's around. They're going to go, well, enough voltage. Yeah. See it all too often.
Got something back there?
Yeah, how about repair integrators, refrigerant leaks? You guys do any of that soldering and repairing?
So for the most part, we try to stay away from under the bars. We definitely can and do bring it to our shop, and we would probably do it for you if you're near Rochester. But I have a couple, local guys that I reference that just focus on doing, ice machines and under the bar coolers. It's just
I've got portable ones. I've got one that I've been
struggling to
fix it. I will replace it.
And honestly, most guys at those sizes, a lot of guys are going to say, buy a new one. Yeah, throw it out, buy a new one.
Yeah.
And the further we go down the rabbit hole of refrigerant changes, I don't know if anyone keeps up to date on EPA and the changes of refrigeration, but everything's obviously going towards the AL2 refrigerants, which that's why keeping maintenance up on your breweries is going to be huge, guys, because if you have to buy new equipment and even new chillers nowadays, the technicians that have to work on those chillers, it's not getting any cheaper. The specific tools we have to have, and gauges are specific to some of these newer refrigerants, and just to call out and fix some of these newer things are going to be exponentially more expensive than it was for maybe the last chiller you had, because the evolving refrigerant changes. It's not totally in the chillers yet. We're still using a lot of the HFC refrigerants, but it's definitely coming down the line where it's going to be changed, and then we're going to have specific equipment to come and fix that thing, and it's the price of having a guy come to fix it is going to go up quite a bit.
Did you have something? Yep.
Yeah, so radiator vents, obviously keeping them clean, allowing airflow is great. In my experience, they tend to get bent pretty easily.
Yep.
Is that ever anything that can be replaced, or is that once they're bent, you just kind of got to replace the whole system?
So, even on Amazon, they make a fin straightener. It's basically a tool that lines with how your fins are spaced. You kind of start at the top, work your way down, and you can straighten a lot of that stuff out.
Okay.
If it's if it's really bad, if you're getting into the fins, then I would suggest a condenser change out, swap. But it's got to be really bad to get there. They make them pretty cool, and it works really well too.
Good question. What's up?
On chiller talk, what about a little bit of water cooling on your fins on a real hot summer day when you're pulling?
So I definitely don't suggest it. I know guys do it to try to gain a little capacity. If you're kicking out on high head, you're probably experiencing it maybe during knockout, or like when you're crashing maybe a bunch of beers. I would say you probably need to be cleaning out your condenser a little bit more. It might look clean, but they're sometimes 2-3 inches thick, and getting that foaming material, and you spray it not only from the outside. A good technician really should be removing your fan motors out of your condensers and doing it from the inside, and then spraying it outwards towards the back of the front of your condenser. If you're having to do that, I would say you probably have a little bit of a restriction, or maybe you might even be overcharged in your system. Because most chiller manufacturers are designed and have big enough receivers to kind of have a wide swing. I mean, if you're going above 60, 70 degrees on your liquid, I might expect you to kick out. But realistically, by adding your city water on top of your piece, you're eventually going to end up getting corrosion on that condenser, and you're going to drastically reduce the life of your condenser. So I would say kind of fix the problem for what it is and make sure you have good airflow going through that condenser, the fan motor's running properly. And realistically, if you have that big of a load and you can't keep up with what you have, maybe consider a bigger chiller.
Yeah, I think in our experience, it's an airflow.
Yeah.
And it's a Band-Aid to get you through those 98
Mhm.
days while you're knocking out and
Yeah.
crashing.
Yeah, I mean, I know guys that do it and it does work and it's good, but I mean, you got to remember you're putting city water with chlorine, magnesium, calcium. Like you're actually making the problem worse
Right.
eventually by doing that.
For us, what we'll do is it's a time thing during. So you turn it on, then you turn it right off.
Yeah.
To minimize that. But
Yeah.
to protect you from hitting those upper limits.
So I would almost bet if your refrigeration charge and everything is good, if you got the foamer, like literally took your fan motor out from the inside, foamed it from the inside, foamed it from the outside, and then sprayed with a good, not high pressure, but good pressure hose back out the side, you'll be surprised with how much stuff will probably come out of the center of your piece.
Yep.
Because that really shouldn't be happening.
It's usually a three-piece thing. It's knocking out, high temps, and cottonwood.
Yeah.
And when that's happening all at the same time,
You're done. Yeah. Oh yeah. Yeah, that's a quick way to kill your compressor usually.
This foam you keep mentioning, is there a good foam to use to clean your fan?
Yeah, it's called Foam Bright. If any HVAC technician should pretty much have it on their van. I think you can buy it online. I'm pretty sure you can buy it online. It's called Foam Bright, and it mixes in like a fruit tree sprayer almost is what we use. I think you mix it like 30% to 70% water with warm water. You spray it in there on both sides, and then it foams from the inside out, so it pulls a lot of that stuff out. And we run into a lot of places where, like I said, the condensers look clean. You can go up to it and be like, man, it feels like I have good airflow. This thing looks clean. You go in there with the Foam Bright and they haven't done it in 2-3 years. You get a lot of cardboard dust, like smaller particle dust, and things that get into the center. Like I said, some of those condensers can be 3-4 inches thick. So, just because that first inch layer isn't good, that doesn't mean the middle of 2-3 inches is completely jam-packed. A lot of times, if you look through your condenser, you can kind of see barely through it, right? Kind of see daylight on the backside. If you're not seeing daylight when you're kind of looking through your condenser, the middle of your condenser is probably pretty plugged up. And I would expect, especially if you're running water and things too, you're almost going to collect it a little bit more as well. So, yeah, Foam Bright cleaner, little fruit tree sprayer, mix it with some warm water, and then a real good hose from the backside. Sometimes you can wrap the electric motor, your fan motor, with like a plastic baggie and then spray it. We usually recommend just 3 bolts or 4 bolts taking it off, just laying it out of the way real quick so you can get in there real nice.
Nice. So now you guys are perfectly pros. What's up?
A question that will reveal my ignorance on.
Okay.
So, glycol chiller had a lot of trouble this winter, especially operating it, when the outside temp was very and so had a first experience with a tech whom I'd never worked with before. Gave me some advice, some of which the tech from the manufacturer was like, oh, maybe you should get a different tech. And so I don't know, that makes me concerned on trust, And, but one of the things the tech that I don't know about was advising me not to let the temps of my glycol get warmer because it would damage the chiller. And I just wanted to kind of validate that with you. Is that, is letting the glycol get up to 60 degrees going to damage my condenser in any way?
It's a loaded question. It depends on the design, to be honest with you. I mean, 60 is definitely a little higher than we usually like to see, right? A normal brewery chiller, most guys are running 28 degrees, maybe go down as low as 26, 25.
Mine
You
is
know-
set to operate at 40 in general.
40 in general. Okay, wow. I mean, if it's a brewery chiller, most of them are designed to run a little bit lower than that. 40s within that range. Getting up to, 60, 70 degrees is definitely a little high. What you run the risk of is tripping out on high head, and it puts an extra load and strain on the compressor. So it's definitely not great for it, but if it's designed properly and it's a good chiller, it should be able to handle it. There's safety devices in a chiller that if that pressure gets too high, it should be kicking it off. On our chillers, there's actual manual resets. So when you trip out on high head, it's not going to start back up until you physically go and reset it. And that's the same case for a lot of chillers. There's manual resets on those. And I tell you what, if you got to reset a manual high reset on your chillers, that's like a dead indication you guys should be foaming out your condenser. You're not getting enough airflow through your condenser. You're not removing the heat. Refrigeration is all about the removal of heat, and we remove it with that condenser.
For me,
So
the problem was always low pressure.
low pressure with a high temperature,
Yes.
that's
At negative.
sounds like there's something you should really get a technician probably in there to diagnose that. 'Cause it sounds like you
Which
have,
we did, and it's running now.
yeah.
Again, I'm not entirely sure on trust with it.
Low pressure is either going to be like an indication of either low freon, or low pressure could also be, if it is properly charged, a frozen evaporator. So check your glycol concentration, make sure it's up to snuff, and make sure where your heat exchanger is, if it's a brazed plate or a coil tube, make sure it's not frozen, because it can build a layer of ice in there, and now you're just trying to remove heat or cool your liquid down with just an ice bath. You're not actually getting a great exchange. That's if you're doing that though, like if you're low pressure and you are plugged up, your heat exchanger's plugged up, that's when you would see the ice ball come form back to your chiller, because it's not removing heat, so refrigerant's kind of still boiling off as it gets back to your chiller, and usually your chiller becomes a full ice ball. So if it's not doing that, then I'd say you're probably low on freon, or something else is kind of kicking in, maybe a bad TXV valve or whatever it might be.
Sounds like one of the UPS guys needs to.
Yeah, are you between Rochester and Buffalo?
Yeah, I have an inline, solar, three-phase, with an inline, phase monitor.
Nice.
It doesn't seem to really go up, so I'll take a lot of fluctuations. Another one I could add on in the series or something, or?
Sorry, so you're saying the phase monitors all over the place?
It doesn't seem to be really robust, so it takes a lot of fluctuations anyway, where I'm located. And so over time, I end up burning out power.
Because the phase monitor isn't catching it, you think? I mean,
And the tech even admitted that.
really? Yeah, I mean, they definitely make a wide range of quality phase monitors for sure. We recommend an ICM. That's what we put on all of our chillers. That's what pretty much the industry standard. Maybe it's not programmed right. That's kind of hard to say, but yeah. I mean, your pump burning up could be a couple different things as well, right? There's a lot going on there. Just because you put a pump in line, like let's say a glycol chiller pump, and these manufacturers can be guilty of this, is you get a nice pump, you put it in there, you turn it on, it's wide open. Depending on your pump curve of that pump, if that pump isn't capable of hitting some of the things you're trying to give it, you're gonna overload that pump and it's gonna burn them up. So a good technician should be able to go in there and check your amperage, which is right on your faceplate of your motor, tells you where you need to be. If you're above that, you're gonna burn your motor up. And that's not a voltage thing, that's an amperage thing, that's your draw. So a lot of glycol pumps and a lot of chiller pumps we see kind of burn up and burn out because they're pumping too much, and they're trying to do too much, and it's not within their spec of their curve. So the motors end up running a little bit over amperage, which then gets them super, super hot. I mean, I would feel your motor. When you get back there, put your hand on your motor. Can you put your hand on your motor? Is it so hot you can't keep your hand on there? If that's the case, you might what I would tell you is restrict your outlet back halfway and see if the motor cools down. If the motor cools down, then you're probably overamping your pump and your pump isn't big enough. To be a phase monitor problem, I don't, it's pretty unlikely.
Yeah. Alright, are we out here at 150?
We got a couple minutes.
Alright. Any last questions?
last-
I mean, off season? Feel free to come by.
Yeah, our booth is upstairs. You guys can swing by too.
4546. Happy to talk for as long as you want.
All right, thanks guys, and thanks for supporting the association.